Op de plaats waar in 1958 het ZETA-experiment werd gedaan, staat nu het grootste onderzoeksproject van de wereld. De Europese gemeenschap heeft samen met Zwitserland de krachten gebundeld in JET, de Joint European Torus, een testopstelling die de fusiedroom dichterbij moet brengen.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Well, 1991 was a real high point of our program for us. Many of us had waited 35 years for 1991. You know, we have done all our experiments in a material called deuterium. And to use deuterium in the way of testing fusion is like trying to light a fire with wet grass. Now, in 1991, for the first time, we poured some petrol on the wet grass. And this petrol for us is tritium, which is the real fuel for fusion. And using it for the first time in 1991, we were able to confirm our best expectations. We found that really we could produce, for the first time here on Earth, fusion power at the level of megawatts for a short time. A time only perhaps of 1 or 2 seconds, because in this time, the interaction with the hot plasma with the wall releases minute quantities of impurity, which cools it and extinguishes the reaction. This now is a central problem for us in the future. We have to control the interaction with the walls so that the impurities from the walls don't get into the plasma. Here we are at the subject and the heart of our experiments, the JET experiment itself. In there is the plasma. Now, over the last 20 years in fusion, we've made huge progress. We began and we were a factor of 1,000 away in the critical parameter from where you need to get to build a fusion reactor. This critical parameter is the product of how much plasma, how long we can confine it, and how hot it is. A factor of 1,000 we came in the last 20 years. In the last 10 years, a factor of 100. In the last 5 years on JET, a factor of 10. We have another factor of 5 or so to go. And we know from the results on JET now how to get this factor of 5 by building a larger apparatus. And this leaves us with the problem we've discussed already, the problem of impurities. We have to keep this plasma pure. We have to keep the impurities out of it. This essentially is the last physics problem to be solved before we can build something of reactor size. And this something of reactor size is a device which is to be called ITER, for the International Thermonuclear Experimental Reactor. ITER is going to be about 3 times the size of the apparatus that you see here.
So the closer you get to the end goal of fusion, the bigger the machines has to be.
That's right, and that's a problem for fusion. Fusion, as we carry it out here with magnetic confinement, really is not possible in very small sizes. And we need very large apparatus, close to the size of a future generating station, in order to demonstrate the effective solution to the engineering, technical and scientific problems. That's a problem for fusion. It involves large expense. It puts us in competition with other projects.
What is ITER going to cost?
ITER is going to cost about $5 billion, so it's going to be an expensive apparatus to build.
Using control. You want me to leave that on for now? Just watch it, yeah.
You lift the floor and then drop it down. You out? You out, Bren?
Yeah, I'm just coming out now.
Okay.
I'm still here.
Do you think it will be possible to make a power generator?
It will certainly be possible to make a power generator. The question will be then, how much does it cost? And is this cost such that people are prepared to pay it compared to other systems? I think we should accept that fusion will be more expensive than other systems. More expensive, for instance, than a coal-fired power station sitting on a coal field. certainly much cheaper than a coal-fired power station that's not allowed to produce any carbon dioxide because it wouldn't work at all. Probably about the same price as the present generation of nuclear fission reactors. Now, whether people will be prepared to pay this premium for fusion power depends upon its advantages, its environmental advantages and its safety advantages. So how are we doing with the mechanical supports?
We're doing very well at the moment. You know, we had our problems with them, but we're winning.
Wat is te doen?